Okay, on this video, I'm going to show you how to solve a system of equations by graphing the two lines. So keep in mind when we have a system of equations, we have two equations. So there are an infinite number of x's and y's that work in one of the equations. That's why it makes a line. Every ordered pair on the line represents a pair of numbers that works in the equation. So when we add another equation to that system, there's also an infinite number of pairs of numbers that work in that equation. But there is only one x and one y, or one ordered pair, that work in both equations at the same time. So if you graph them, the place where they intersect, or the place where they cross, is the answer to the system. It's the x and the y that work. So if we take this top equation, y equals x plus 2, and graph it. So I'm going to go up to 2 on the y-axis. It has a slope of 1 over 1. So I'm going to go up 1 over 1. And I'm going to graph that line. I'm doing this in pen. It's a good idea to do it in pencil. Then this one is plus 9. So I'm going to go up to 9. It has a slope of negative 3/4. So I'm going to go down 3, 1, 2, 3, to the right 4. 1, 2, 3, 4. And a lot of times when you do that, you'll get the point of intersection without having to sketch or extend the line a lot farther. Okay, so we can tell that it crosses right here at that point. So I'm going to zoom in on that a little bit. So that is x equals 4 and y equals 6. So it's the ordered pair 4, 6 that works. So if I plug 4 into this equation, 4 plus 2 equals 6, and if I plug 4 into this equation, 4 divided by 4 is 1, 1 times negative 3 is negative 3, negative 3 plus 9 is 6, I get 6 both ways. 4 is the only number I can plug in for x into both of these equations and get 6. It's the only ordered pair that works. Okay, so let's come over here and do this one. If you want to pause the video and work this example and then see if you get the same thing I get, that'd be great. So plus 1 goes up here. The slope is negative 1/5, so down 1 over 5. So I'm going to sketch that. This one is minus 4 for an intercept. It has a slope of negative 6 over 5. So I'm going to go down 6 to the right 5. 1, 2, 3, 4, 5. And I want to make sure I do this really straight. So I'm going to go up 6 to the left 5. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. And same thing here. If I would go up 1 over 5, I would see that I would land there. So slope is like a staircase. If it's down 6 over 5, it's going to continue that 6 over 5 slope all the way through. So this point is at negative 5, positive 2. So negative 5, positive 2 would be the solution to that system. Okay, down here, it's written in standard form. So I'm going to show you a couple different ways we could do that. The bottom one, I'm going to solve by finding the intercepts. If we plug 0 in for x, then y is equal to negative 5. If I plug 0 in for y, then x is equal to negative 40. Now, when you go to try to do that, you're not going to be able to plot it. But it's good to try it that way, because if you plug those two numbers in, if you plug 0 in for these two numbers and solve, it's easy to see what the intercepts are. Now, it's not so easy to graph it because I don't want to sketch this graph out to negative 40, but it's a good habit to get into to think about what the x and y intercepts would be. So if we rearrange this, you would have 8y, oops, sorry, I can't see that. 8y is equal to negative x minus 40, and then divide by 8, y is equal to negative 1/8 x minus 5. So that agrees with our y-intercept. We go down to negative 5, and then the slope is negative 1/8. So down 1 over 8, and I would go up 1 over 8. So that's what my line looks like. If I start with this one, I'm going to have 8y is equal to negative 11x plus 40, then divide by 8, negative 11 over 8x plus 5. So this one starts at positive 5 and has a slope of negative 11 over 8. So 5 and 6 more, and then over 8 is going to land at that point. And so this ordered pair is 8, negative 6. So 8, negative 6 would be our solution. Okay, this one, if I do intercepts, I'm going to cross at 9 and 9. Like whenever you have x plus y equals a number, that number is your x and y intercept. So I'm going to go over to 9 and up to 9. So I'm going to have a negative 1 slope. So it's going to look like that. Then this one, I'm going to rearrange. So that's going to be there we go. Negative 7y is equal to 21 minus 5x. I probably should have rearranged that, so I'll turn it around when I divide. So divide by negative 7, that would be 5/7 x minus 3. So I'm going to go to negative 3 for my y-intercept, and then my slope is positive 5/7. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6, 7. And if this line was straighter, it would go through that. So I just connected that and that without using a straight edge. But if you go through each rectangle and you make sure that you do a negative 1 slope every time, then you're going to see that it exactly would go through that same point. So that ordered pair is 7, 2. Okay, so that's how you do those by graphing. Let's do one more by graphing. So subtract, or minus 2 means I'm going to go down on the y-intercept. The slope is negative 1/4. So down 1 over 4. So I also would go up 1 to the left 4. And so looks like that. This one is up 1, and it also has a 1/4 slope. So down 1 over 4. And so it is going to be 2 parallel lines. So they are never going to cross. So when you have something like that, you say no solution. There is no number that you can plug in here and also in there. So when they have the same slope but different y-intercept, they're never going to cross, so you have no solution. Okay, that does it for solving a system by graphing.